KTGS Northfield students and community members, Mr. Jaquette here, excited to talk to you about some of the concepts we are going to be learning about on Math Day. Math Day, a celebration that math is all around us and that thinking mathematically creates a more joyful life and helps you be more successful because you can analyze the world around you and make better decisions. Now on Math Day, we have two stations that are going to be featuring probability. Probability is the likelihood that an event will happen. I could go to the roulette wheel and say, I think the wheel is going to land on black. There are 18 different things that are on the wheel. There are 18 different black numbers on the wheel, 38 different possibilities. I have an 18 out of 38 chance of landing on black. Hey, black 24. There is also going to be a carnival station. In the carnival station, students are going to get a chance to play a skill-based game, see if they can't get, for instance, on this game, the ring to land on the hook. And we are going to be calculating our probability by seeing how many successful outcomes we had versus how many total outcomes we have, and then expressing that as a fraction. Before talking about the games though, let's just talk about what probability is. Probability is the likelihood that an event will happen. Probability is usually expressed as a fraction or as a percentage. As a fraction, the numerator is going to be the opportunities for that thing to have happened, the successful results. And the denominator is going to be the possible outcomes that there could be. So let's use a coin for that example. Let's say I want to say, what's the probability that this coin will land on heads? Well, there is one head on the coin, so one on the numerator, and what are the total possible outcomes? Well, there's a heads and a tails on this coin. So there are two possible outcomes. So the probability that it lands on heads would be 1 over 2, and we know 1 divided by 2 is 0.5 or 50%. So I have a 50% chance of landing heads. Heads it is. Another way to think about probability is a dice or a die. The probability that I'm going to roll a 4. Well, there is 1 4 on this dice, and there are 6 possible outcomes. So the chance of rolling a 4 is 1 in my numerator and 6 in my denominator. It was a 6. So the probability of rolling a 4, 1 out of 6 or 16.6 repeating percent. Let's use that same die. We can change the way we're thinking about probability. What's the probability that I'll get an even number? Well, evens, 2, 4, and 6. So 3 would go on my numerator. There's 3 different ways I could get a win and successfully roll an even number. How many things are on the dice? 6. So my probability of rolling an even number is 3 out of 6, which we would reduce to 1/2 or 50%. I got a 4, got an even number. Cards also have good opportunities for probability. There are 4 of each number or face card in a deck. There are 13 of each type of suit in a deck. There is 1 particular number and suit. So right now, if I flip over a card, the chance that it would be an ace of spades would be 1 out of 52. 3 of spades. If I wanted to flip over a card, and what's the probability of it being a heart? Well, there are 13 hearts in this deck, 52 cards, so the probability of it being a heart, 13 out of 52, which reduces to 1 over 4, or 25%. It was a club. The probability of it being a 6, there are 4 6s in this deck, so the probability that this is a 6 would be 4 out of 52, which reduces to 1 out of 13. Oh, not doing too well on my cards today, it was a 5. So probability in our casino station is going to exist just like that, theoretically. There is no skill involved. When I'm spinning the roulette wheel, the probability that it lands on an 8 is going to be 1 out of 38. There's 1 8 on the roulette wheel, 38 different things that are happening. That's very unlikely that it would land on an 8. So if I spin this, I can know that 1 8 that would happen, it was a 24, didn't land on 8. That's how we're going to experience probability in the casino station. But in the carnival station, we're going to be playing some games that include skill. It's not just theoretical. What is my probability of success when I try to play this game where I'm trying to get a hook or a ring onto this hook? What you're going to do is first, you're going to estimate. You might say, I think I can land this ring on this hook 1 out of every 4 times for a 25% probability. But then you're going to get a chance to actually practice. And because it's a skill-based game, you'll probably get better. You're going to record your data as you go. let's see how many times I can get the ring onto this hook in 10 tries, and then we'll use that as what my guess is for my probability. So let's see how I do. 0 for 1, 0 for 2, 0 for 3, 1 for 4, oops, that one doesn't count. 1 for 5, 1 for 6, 1 for 7, 1 for 8, come on, Cartal, 1 for 9, 1 for 10. So in this particular experiment that I did, I had a 1 out of 10 chance of getting this ring on this hook for a 10% probability success rate. If I kept practicing, that actually might increase, which is fun about these skill-based carnival games. But that's just a way that we're going to be thinking about probability. Hopefully this video helps to prepare you to think mathematically during our math day. Really looking forward to having fun with students on this and learning more about probability and how to make better decisions in our life because we understand to think mathematically and we find math to be a really joyful addition to our life.